Hi there once again and welcome to another Expresso mechanic tutorial. And this is number 8 in the series of Expresso nuts and bolts. In this one we're going to be looking at another of the Expresso presets, the system presets, and this time we're going to be taking a look at the trigger distance node. We'll be using this in combination with the Python node because there will be some code involved in this and of course some dynamics for the sphere, bowl and bumper. That's what we're about in this tutorial. So without further ado, let's see if we can make this happen. Before we start looking at Expresso, Python and dynamics, I'll just take you through what we've got on the screen. So the sphere, which is going to be pushed around, is an icosahedron. I felt that it would give me better results if I used that as opposed to a standard, so that's why I've set it up that way. Radius of 20 and 40 segments. I left the random perfect checked, that's fine. Moving on from here, the bowl is actually a hemisphere. I made it editable because I wanted to take away the top 2 rows of polygons. I didn't want those in, so I just took those away just by going into my polygon mode, selecting with UL for loop selection and then delete obviously to just take them away. So that's what I did there. The bumper, this started life as a cylinder. If we just hit F3 for right view, no, don't want those, thank you very much. And you can see here that we've got an object that's just simply been fashioned into shape. That's all I did there. I just tugged vertices effectively until I got the shape that I wanted, and that's it. That made the bumper for me. And if we just look at the dimensions of this, we can see that if we just go back to object mode, we can see that it's about 100 centimeters in diameter and 56 in height. Now the ring for the bumper, which is the last object on the screen, not complex object, but it started life as a simple cone and I did some work with it. So what I'm going to do, I'm just going to go into a new project and just show you how I did that. So grab a hold of a cone. What I did, we go into Garage Shading Lines. In our object, we've got a top radius, a bottom radius. The bottom radius, I'm just going to make 50 for the sake of this, and the top radius 40. The height I'm going to make 15, and that looks about right. I mean, this is not necessarily absolutely accurate to what I did, but it's about the technique more than anything. The height segments I'm going to leave for a second. The rotation segments I'm going to leave those as well. Now the caps, we want an extra segment there, and that's fine. So we've got our object, and our height segments we don't want 4. Let's just take that down to 2. Okay, that's great. So we can say hit C and make this editable. Go into edge mode and UL. Select the top inner edge there and the bottom inner edge. Select the scale tool, and then we don't want to scale in the Y, so we'll just lock that there. Looks like I'll have to reselect, so do that again and that again. And with the scale tool, just move them until we get them in the right position, which is somewhere around there. That'll be fine. So that's done. Next thing to do is go into polygon mode, UL again, select the top inner polygons and the bottom inner polygons. Switch the display to lines. I'll also switch to isopalms, not that it'll make a great deal of difference, but I prefer to work with isopalms because it makes things a little bit less complicated a little bit later on. And then we can say MB and create a bridge, so we can bridge between here and here. And that's created the ring. Now if we go back to Garage Shading Lines, we'll see what we've got. The next thing to do is to work with this bottom edge, just the bottom edge. So UL and select the bottom edge, and then in the front view or the right hand view, as I've selected there, we can select the scale tool again and bring this in until we get it by eye just about right. That'll do nicely, I think. And that's created the inner part of the ring and set that up as we need it to. Then we can say UL again, select this inner set of edges, scale tool again, and just bring those in to somewhere there. So that's got that the way we need it to be, and we can then simply hold down our Alt key or our Option key, select a subdivision surface and place the cone inside that. And then really it's just a case of tugging vertices and making the thing as we want it to look. So we'll come out of isosceline editing, don't want that. UL, and we'll select the inner edge here, the outer edge here, this outer edge, and this bottom inner edge. And then we can hold down our full stop key, click and drag. And we get the shape, and we've got the basic shape of our ring then. And then all I did was put a bevel inside there. I'll just hold down Shift, grab hold of a bevel deformer, and there we are. We've got it. We can, let's have a look. Subdivisions we'll say 3, and probably make that a little bit less, maybe 0.5. Might be all right. That looks pretty good actually. Yeah, it looks quite nice. So we've got a good result there. The only other thing we need to do is probably do a little bit of work, because we look as if we've got our edges a little bit too taut, but that's okay. If we can just select those, just take them back a little bit, that's fine. Just relax those edges. Now we've got the bevel there. We don't need to worry too much about that. And there you go. That's your ring complete, and that's how you make it. So that was just worth going through, I think, because it's a little bit more complicated than some of the other things in the scene. But anyway, let's switch back to our original project, and we can carry on working from here. The next port of call for us is to take a look at the dynamics. So with the sphere, we'll add a simulation rigid body tag. Now, I'm going to take the friction down to 50%, and I'm also going to say use margin, and we'll leave that checked. The shape can stay at automatic. You can leave the rest of it the same, basically. Don't need to change anything. Don't be tempted to use convex hull, because it will just slow things down. Just leave it on automatic, it'll work fine. So that's the sphere. And then with the bowl, the bumper and the ring, they all need to be static meshes. Static mesh is. I'm not drunk. That's what they need to be. So we need to select both of those. We also need to select our cone, and we will give them collider bodies. Now, we can set these up in different ways. They can all have slightly different settings in them, but it's entirely up to you to have a play around with this and see what you want. Now, the bowl, I don't want 100% friction, and you can leave the bounce at 100%, but the friction maybe 50. That should be okay for that. The bumper, yep, you can leave that as it is. Not a problem again. That will be perfectly good. Again, we can say use margin, and I'll also go back into my bowl and check use margin. That's fine. That's all looking good. And that will work out pretty much okay. Finally, this ring here, what we can say in here, static mesh again, of course, use margin. And again, I don't want 100% friction really. Bounce we can probably leave at that, but the friction we can take down maybe to 50% as a starting point. So that's the dynamics. I mean, you say nothing clever in the dynamics. It's just a few settings that you need to change, and the rest you can just leave them alone, because it just doesn't make any difference. But that's the dynamics set up for now. If we need to do any tweaks, we can do those later. Moving on from here then, we can grab a null object and put it in the scene, and we can rename it Expresso. Give it an Expresso tag. And we've got the Expresso editor open, and we're ready to start work. I'll open my system presets and come down to the calculations menu here. And we've got trigger distance hidden away in there. And if we bring this in, we can take a quick look at the node and see what it actually has. So at the input stage, we've got a position 1, position 2 and trigger distance. At the output stage, trigger and distance. Now, this is very similar in the way that it works to something which you've seen me code on a number of occasions if you've done any of my effector tutorials, Python effector tutorials. I've put a card up on the screen so that you can have a look at one of those if you wish to, that features the code that actually represents this. So what we've got here is position 1. Now we're going to bring in our bumper and we're going to say coordinates position, position. We don't need to work globally because it's not grouped. Our sphere, we'll bring that in too. And again, we can say coordinates position, position. And we can connect these two to the position 1 input and the position 2 input. Okay, that's great. Now, if we click on the node, we can see that we've got trigger distance down here. And at the moment it's set to 41. That's the default setting. We need to set this to a different value, and we can look at doing this shortly when we get to the stage where we can actually have a quick look at that. Now the trigger here is a bool value. So if we put a result in there, I should say, from the general menu, if we grab a result, put that there, and we connect that up, at the moment we can see that there's a 0 in it because the trigger distance hasn't been breached. And we've also got a distance output, and we can place that in there. Now that's telling us the distance between the bumper and the sphere as they stand at the moment. And this is where it's similar to the code that I mentioned. What we're actually getting here, where we've got the two objects here, what the node is actually doing is subtracting the position of the sphere from the position of the bumper. But anyway, by doing so, it's creating a difference vector, which you may have seen me code. Now the trigger distance is the distance that we're saying we want to check. We're saying that when we're within this distance, we will want this trigger to be 1, and that will make something else happen. That's what we're wanting to do there. So the actual distance is a distance vector, which of course we get when we subtract one from the other and then get the length of the resulting vector. That gives us a distance vector. So here it's a difference vector, and here we get the distance vector by measuring the length of the difference vector. So you've seen me, as I say, do it with code. It's exactly like that. So that's what we're doing here. So let's see if we can get this to work. If we run the timeline, our sphere now rolls towards the bumper. Now at the moment you can see that we're still getting 0 because it's saying 41 in here. And we're at the moment, we're at 56.315. That's where we're actually at. So if we change our view to our front view and we hit H on the keyboard, we can take a quick look at what's actually happening down in here. So we can now see that we're just about where we need to be. What I'm going to do is actually set that. Well, I'm not going to use 56. I'm going to use 61 in there because that gave me quite a nice result. Now you can see here that now we're getting a 1 at the output because 56 is obviously less than 61. So we're close enough now to the bumper that we can trigger something here. And that's great. That's what we want. So that's essentially where this node is doing its job for us. That's what it's doing. It's allowing us to sense the distance between the bumper here and the sphere. And when the sphere is within a certain range, it's going to trigger something. And the something that's going to be triggered is the ring. This is going to shoot down, shoot back up again, and in the process, it's going to knock the sphere away, as it would do in a pinball machine. That's what we're about here. So the next thing we need to reach for is the Python node. So we'll bring that in. Okay, great. And as per usual, I'm going to remove the input ports. We just get the information on the output port. We'll see what we've got. It's a real value, and that's fine. we're going to rename it and call it pos_y. And at the input stage, I'm going to add an integer and again rename this, and I'm going to call it bool. And that's fine, that's got that set up. That's as much as we need to do there. Now the trigger will be plumbed into the bool input. And then we can start working on our code. What we'll do, open in Python editor, and we'll switch to a scripting layout. Once more, I've got to reselect this. I wish this worked in a different way. It would be better if it did. If you could just do that and it was there, it would be okay when you went to the script. But there you go, it isn't. Python. Okay, we're all set up and ready to go. So, global position Y is the first line that we do need. That's automatically in there. We now need to add a couple more global variables, and they will be global trigger and global start time, which again, if you've seen any of my Python Effector tutorials, you will have seen me use before. Okay, great. So those two are in. And now it's the ubiquitous frame variable, which again, you've seen me do a number of times if you've seen any of my other tutorials involving Python, or a number of my other tutorials involving Python. So it's get time, open close, dot get frame, open doc dot get fps, open double close. And I'm going to say it again for anybody who hasn't seen it. This just simply gets the frames from the timeline. It gets the current frame from the timeline. Okay, we can then add some user data, because we are going to be using a monoflop, or we're going to be coding a monoflop in here. So we're going to add some user data. We'll call it spline because that's what it's going to be. So we'll come down into here and select spline, and that's fine. We can OK that. We can then set it up. We need a bell curve, so we'll just put 3 points in, and then we'll start setting this up. Let's twirl this open, and the midpoint here, we need to set it at 0.5 in the X and 1 in the Y. And then we can start working with our points here and get these set up the way we want them. Now 0.25, let's see if that's going to work for us. If I set this to minus 0.25, and then these can both be minus 0.25 and 0.25. That should give us a nice bell curve. Maybe a little bit too slow to react. So what we'll do, instead of using 0.25, I think we'll go 0.125 on all of these, because it will just make it that bit faster. So minus 0.125, and then here minus 0.125, and that should tighten it. And I think that will work better. That will give us a better result. So we'll leave it like that. That's great. So we can now get a hold of our spline, just drag this in here, and then say spline is equal to op, and we're there. That set us up. So we're now pulling this user data into here. Moving on from here, we can say if frame is equal to 0. And this is where we initialize things. So we need to say trigger is equal to an empty list, start time is equal to an empty list, and position underscore y is equal to 0. Because our ring, I've got it set up here in a null. If I just change to the position axes as opposed to the scale axes, we can see that it's set here. So this will be its start position, which, given that it's grouped into the null, will be 0. So that's why we've set it up like that. Moving on from here, we can say if bool is equal to, helps if you spell it correctly, not like that, that's it. If bool is equal to 1, so if we're getting a positive value here, we know that we've got to make something happen. So we can say if len trigger is less than 1. So if there's nothing in our trigger list here, we want to put something there. We can then say trigger dot append 1. Similarly, with our start time, we can say if len start time is less than 1, start time, not strat time, I haven't got one of those, start time dot append frame, because we want the current frame. And then it's another if statement. So if len trigger is equal to 1, and this is where we want to create our monoflop. We can then say duration is equal to frame minus start time square brackets 0. So whatever's in our, whatever frame is in our start time, we select from the current, or subtract from the current frame, which zeroes things out. So if we're at 30, we're going to subtract 30 from 30, which is going to zero things out. And then from there, we're going to be using our duration for our monoflop. So we want this to happen quickly. So we're only going to do this over 5 frames, because obviously a bumper, the ring on a bumper, really flicks down and up quickly in order to do its job. So we'll say if duration is less than 5, we can then say range mapper is equal to c4d.utils, because the range mapper is stored in the utilities module, dot range map, oops, helps you spell it correctly, map. And we can say, that's better, duration, comma, and it will be 0,5. As we said, we wanted the input range to be 0,5 because we only want it to happen over 5 frames. And then 0, minus 35. So over 5 frames, the ring will drop down by 35 units and then shoot back up. That's what we're going to do. Because we're using a negative value, we need to say false, and then comma spline to finish it off, so that the data is mapped via the spline that we created in our user data. We can then say pos underscore y equals range mapper, and then moving on from here, we need an else. So else trigger dot clear start time dot clear open close, and finally pos y equals 0. And that completes our expression. We don't need to do any more Python than that. So as soon as we get a 1 from the trigger, we start making all of this happen simply by using a range mapper and a monoflop. That's what we're doing. So the reason I've done it with code is quite simple, really, because if we just get a hold of a monoflop. Now, if I technically you could try using this to actually make this happen, but the problem with it is the trigger, because as soon as the ball moves away from the ring here, this will give us another, it will give us a 0 again. And the trouble is, as soon as the monoflop receives a 0, it will reset itself. So the ring will only go so far, the ball will move away, and then the ring will just shoot back up to 0, because it will reset itself before it's gone through the cycle. And that's the problem with the actual monoflop in Expresso. I wish that there was a checkbox that would say complete the current cycle before you reset yourself. That's a bit of a mouthful, but you know what I'm saying. If it had that there, that would be superb. It would make an already very powerful node, because make no mistake, this is a powerful node, but it would make an already powerful node even more powerful if there was an option to do that, but there isn't. And that's why I've coded it, because I'm saying if bool is equal to 1, then we put something in the trigger. We actually put that in this list, and this goes. It says if len trigger is equal to 1. So as soon as that is equal to 1, then this will go, and it will go until we've gone through this entire process, and then it will reset itself. That's how it's designed to work. So it's actually more powerful than the monoflop node within Expresso in situations like this, and that's why I've coded it. But anyway, let's have a go and see if this works. So if I've done everything right, it should do something, but if there's an error, we'll see it in here, and you know what I'm like, I make a lot of syntax errors, but let's give this a go and see if it works. Right, so there's a problem, isn't there? There's something is not working. So let's have a quick look and see what we've got. Well, we've definitely got a trigger there. Let's just go back to 0, and that bit of it is working, so that's correct. So let's just see what we get. So we're not getting it moving away. We're within the correct distance, but let's see what we've got in the Python node that's not quite doing the job. No, actually, I'm a fool, because the reason this isn't working is because I've got nothing plumbed into there. Right, let's bring something in and make it work. So let's get a hold of this subdivision surface here. Let's rename it. We'll just call that ring as well for what it is. Let's just bring this in, give it a position Y, and plumb this into there. Now let's have a look, see what we've got. It says, where are we? Get time. Okay, I spelled something wrong. I think that's all I've done. Let's just close that down a minute. Where are we? Yeah, get time. I've put an N in there. Syntax. Oops, that's not what I want to do. It's a syntax error. Let's just move that out. And now let's execute that. Trigger is not defined. Yeah, well, it won't be because we're not at 0. So let's just take our timeline back to 0. And let's see what happens. And it's working. We need a few more frames. Let's give ourselves a couple of thousand frames for what it is. And now we'll see it. Let's see if it works. Yeah. And it's working fine. It's doing the job. We've got to wait a bit for it to go back to the right place. There you go. Crikey. That was a good hit, that one. Yeah. And it's working fine. So you can see that what we've done has achieved the desired result. And it's all down to the trigger distance node. This is the key to it, the absolute key node. So, you know, if you want to do something like this, I mean, there's plenty of things that you could do with a node like this, loads of things, you know, so that's how you do it. Just get the positions of the two objects, set up your trigger distance in here, and then where you've got your trigger here doing something, then you can make something happen afterwards. It doesn't have to be Python, of course. It could be anything, you know, anything you fancy coming up with. But Python can be useful for a situation like this where you need a process to happen and you don't want the monoflop to stop working as soon as the ball or whatever is away, too far away from the object that it needs to be close to in order to trigger things. But anyway, that just about completes this tutorial. So, as always, I hope you've enjoyed this one and that it's been useful to you and you've learned something new that you can use in your own projects. And if you have, then please like the video and please subscribe if you haven't already. And of course, leave a comment and ring the bell. And wherever you happen to be on social media, then please do share this video, because all of this good stuff helps to keep the channel moving in the right direction. But anyway, that about wraps this one up. So I'll see you very soon on the next tutorial.